Okay, let's see. Additional feature allow user to specify more complex retrieval from database. Actually, we use this SQL use database because it's quite convenient than using Excel. Sometimes when we retrieve the data or search for the data with several conditions, like if we have Excel of your update students in our class, you have student ID, first name, last name, and many things, right? If we have, we would like to search for the students who start with the name, start with S character, so it's quite difficult using the Excel because we have to do it manually. But if we use the SQL command, we just use one single command and the program search for us automatically, right? So, and if you have several sheets inside the Excel, and we want to join, we use like, have you ever searched several data from several sheets using VLOOKUP? It's very easy to mistake because of some character is not, we have to write the program or the command by yourself, so sometimes it's mistake using the different columns of the data, something like that. But if you use the command in SQL, you just use select the proper attribute name, that's all. Okay, so the complex one of the SQL or complex retrievals from database, we have like nest query. We have like a subset of the command inside the command, nest queries and joined table, outer join, and aggregate function like multiply, plus, min, max, and grouping the data. Okay, let's see detail. First of all, we're talking about the comparison in the database involving now value, and tree value logic. Okay, at first we have to understand about the now, and if we have operation with now value, what is happen? At first, now is mean unknown value, unavailable or withheld value, not applicable attribute. This means nothing. Okay, nothing in the field. Each individual now value considered to be different from every other now value. And SQL use a tree value logic: true, false, and unknown. According to our knowledge about the logic, we have just only two values, right? True or false. But in database, we have one more, unknown. And should not use this one, now equal now. We cannot compare the now, okay? And here is a table to show the result when we use the operation and or not. And or and not. When we compare true and true, we got true, right? True and true, we got true. False and true, we get false. Unknown and true, we got unknown. Okay. Unknown and true, we get unknown. But about false and true, we get false. False and false, we get false. False and unknown, we get false. Okay. But about the unknown and true, similar here, is unknown. Unknown and false become false. And unknown is just unknown. Okay. About or. Okay. First, AND operation. AND. When you use AND, false is the most powerful. Right? False is the most powerful. Always false if you have false in AND operation. But about or, okay, let's see here. False, false, always false. In operation, true. Operation or, always true. Okay. But if you use or, false or unknown is become unknown. And unknown or true, we get true. Unknown or false, we get unknown. Okay. And about not. Okay, not true is false, not false is true, not unknown is unknown. So, the most powerful is here, unknown, for not. Okay? Unknown. Okay, when we have unknown, it means we get now value in the field. So the operation is result become like this one. And the other one, P and Q. Okay, we pair that true, P, true, false, 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 and unknown. And we compare all patterns. Use or and equal. Okay, or and that's already done in previous. But about equal, true and true equal true become true. True equal false become false. True equal unknown become unknown. If we compare unknown, as you can see, if we compare unknown, we got unknown for all of them. As you can see, we have unknown, 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 unknown. If we have any unknown, when we compare, the result have to be unknown. This makes sense. Okay. Can you remember? Maybe not. The data, can you remember? Maybe not. The data supers underscore super SS is mean the supervisor of employee is now only. If this condition is true, we show the first name and the last name of the employee. Okay, so this is how to use, how to compare the now in the condition. Use is now. And next we're talking about nest, queries, tuples, and set multi-set comparisons. Okay, nest query. The first one, nest query. This is complete select from where blocks within where clause of any query. Is actually query in the query. We call nest query. Outer query and nest subquery is how to call them, whatever. So comparison operation is in to connect the outer and the nest subquery. Compare value v within a set of values v. It's a set v. Big character here is uppercase is the set of values, and small one is just the value, our value inside the set. Evaluate to true if v, the value is one of elements in set v. For example, let's see. This is the example command of the nest queries. Queries in the queries. Here is the outer one, okay, and in the blanket is the subquery. Now we have two subqueries, okay. the first one and the second one. Okay, this is the structure of the nest query, and we use in operation, in. So what we going to query is, let's see, make a list of all project numbers. Okay, all project numbers for projects that involve employee Smith. Okay, Smith, Mr. Smith or Mrs. Smith, either as workers or a manager of the department that controls the project. So now we have two conditions. The employee Smith is a worker or employee Smith is a manager, two of them. So we want what? We want a list of the project. So here is the result we want. Just list of the project number. List of the project number. But each project should have Mr. Smith as the employee or manager. So here, what is the first one? Oh, here. Manager equal SSN of the employee, and the employee name is, last name is Smith. So here is when the Mr. Smith or Mrs. Smith is the manager of the project. If you use only this clause, right, subquery, P number, project, from, project, department, employee, we have three tables, right, three tables related to this result. And we compare the department number that Mr. Smith working for, and we list the project also that the Mr. Smith working on, and also he is the manager of the department that control the project. So, but you have to understand that one department managed by position. So it might same value in the subqueries from the two subqueries. So in the result, we don't want to show the duplication data. Then we used this thing to eliminate the duplications. Let's try, maybe we can see session. So it might same value in the subqueries from the two subqueries. So in the result, we don't want to show the duplication data. Then we used this thing to eliminate the duplications. Let's try, maybe we can see. Of course, the result from the second subquery. But if you use the whole command, we don't know where is the result come from, the first one or the second one. But we got the result. Similar. But in detail, we can see that for each subqueries. Okay. So when the database queries, they, of course, the result from the second subquery. But if you use the whole command, we don't know where is the result come from, the first one or the second one. But we got the result. Similar. But in detail, we can see that for each subqueries. Okay. So when the database, when the database queries they and then the outside into out, like a mathematics, similar to the mathematics. Okay, and here we use OR operation, OR. So if here we got 1, 2, 3 project, and the second one we have 1, 2, 3, 4, and we use OR, right? Then the results is become actually 1, 2, 3, and 1, 2, 3, 3 and 4. And after that, when we use this thing, they eliminate the duplication one. Sorry. Just a concept. I have to use the other pen, beautiful one. But anyway, you can understand that, right? And the result show just 1, 2, 3, 4, not duplication. Okay, this is a concept of nest query. But the difficult one is here. You have to interpret the question at first and understand the relation of each attribute or each entity inside the queries. And you have to know what kind of, at first you have to know what is the table related to this question, and what is the relation, what is the key, and what is the foreign key, how to connect them together. Like here is manager SSN. Manager SSN is the foreign key, right? SSN is the key. And you have to know last name belong to which table. Okay. So, and next query, continue. Place them within parentheses. Parenthesis. This thing. Okay, we have the So if we look at the subquery, what is that? Just what is the result of this query? The project that this employee working on, and also the hours, right? How many hours the SSN number 1, 2, 3, 4, 5, 6, 8 working on, how many? So the result is become like just two columns, P&O and hours of this man in the subquery. After that, we just show, but for just this man, right? And show the P&O and hours that equal to this data, and show who work in the same project and works hour equal to this man. Okay. Yep. If this one, we have the project number 1 and hours equal 3. So we use this pack of the two data to search in the works on table and who works in the first project and work 3 hours, similar to ESSN equal 1, 2, 3, 4, 5, 7, 8. Mr. A, okay, I call he Mr. A, okay. From this, these queries, they try to find who working on the same project with Mr. A and work hour of the works equal to Mr. A, 3 hours, and list all of them. Okay. Next is the use Other comparison operators to compare the single value. Okay, we use equal, any, or equal sum operator. Return true if value v is equal to some value in set. And other operators that can be combined with any. Okay, more equal, less than equal, and not equal. Yes, not equal. And all here, value must exceed all values from next query. So, for example, here, select name and the last name and the first name of the employee from salary table who has salary more than all of the member in the result from subqueries. In the subqueries, we select just only salary from the employee where D&O department number equal 5. So we get the result as one column table. Here it is just salary from department number 5. So we maybe get $1,000, $2,000 maybe, and the result show here all of the people show in the result, final result, must have salary more than all of the people or employees in the department number 5. Okay. Next is the general form. General form of all, any, and some. Okay, we have select from where. Select and we project. We select the columns. What kind of column we want to show in the final result. From which table and where condition. Expression operator, we have all, any, some, and you have subquery in the blanket. Avoid potential errors and ambiguities. Okay, sometimes if we have like two tables, we have similar name of the columns, like a first name or the last name or SSN, is sometimes become ambiguous when you use two tables with the same name of the column. So we have to use alias to identify the columns from which table. For example, here we use employee as E. E is alias name of the employee table, and we identify that first name from the employee and last name also from the employee table. And we can use E of the outer inside the subqueries, as you can see here, where E dot F name. That means we try to compare the first name from table employee that we identify our outer, right, equal to D dot dependent name. This one is from D. D is the table dependent, so we can compare. Okay, so we can understand very clear about where is the attribute come from. Refer to which table. Okay, and also sex, E dot sex equal D dot sex. If we don't have the identify the table sex equal sex, we don't know which table we want to use, right? So now is very clear, and if you don't identify, actually it's become the error in the queries. Anyway, don't forget it. What does this mean here? Retrieve the name of each employee who has dependent with the same first name and is the same sex as employee. First name, same first name. Very interesting. So in the subquery, we check the same first name and the same sex with the employee and the dependent, right? And then we list the employee name. sorry, we list just the employee SSN. And we use this list of the SSN to retrieve the first name and the last name of the employees with these conditions. So you have to imagine that from the subquery here, the result we got only one column, right? SSN. From the subquery we got just one column, and the set of people who had the first name equal to the dependent name, similar name, and the same sex. And then we use this list of SSN to query the first name and the last name of them from the employee table and show as the final result. So the final results will have two columns, right? First name, first name and the last name. That's all. The first name and the last name. Here we will show in the final table. Okay, so the other one also similar. Understanding a nest or correlated query. Okay, retrieve the name of each employee who has dependent with similar, right? Query 16. Okay, similar one. For each E tuple, evaluate the next query which retrieve the ESSN value of all D tuples within the same set and the same E as E tuple. If the SSN value of E tuple is in the result, then select the E tuple. So this is the explanation of this query. For each E tuple, for each E, But this explanation, they said that they evaluate, they retrieve E tuple at first for the outside employee E and select one of them, one by one, and use this one to check the first name and the last and the dependent name. If they don't have any dependent name, they don't. The result is become null. But if ESSN had dependent, so then retrieve the name of the dependent and check with the first name of the employee and also check the sex. If this set is true, become return the SSN for each tuple of the employee, then they show the first name and the last name as the result, one by one. And actually, you can change the form of the nest query to the other form, not use the nest, use the other form like this one, correlated nest query. These queries that are nest using the equal or in comparison operator can be collapsed into one single block. For example, from the queries number 16, they can change to this one without any subqueries, right? But they use and. And moreover, here is just focus on one table and one table, right? One by one. But this one, they merge all of them together. So they select the first name and the last name from employee table, and from they identify alias for employee table and dependent here. After that, the where clause here is the check the SSN equal ESSN. This one is from dependent table. After that, they use AND operation. Sex of the employee and sex of the dependent should be equal, and the first name and the dependent name should be equal. So it's more simple, but it's quite more complex to understand. But it's your side. It depends on your side. If you got the correct result, that's fine. But difficult for me to verify which one is correct. If you have several patterns, it's very difficult to score in the examination. But that's fine. I will try my best. Okay. Correlatedness query evaluate once for each tuple in the outer query. For the nest, they retrieve the subquery step by step from the outer and compare to the inner for each one, or for each tuple of the outer. But this one, they do everything at the same time. Okay, so what else? Here is the exit and unique functions in SQL for correlating queries. We have exit function. This one check whether the result of correlated nest query is empty or not. Exit, okay. And they are Boolean function that return true or false result. And exit and not exit typically used in conjunction with correlated nest query. And SQL in the department, anyway, if possible, please try to use alias every time. Maybe when you check the data, it's more clear. Check the command is more clear and not confused. Okay, the first one, select everything from dependent where SSN actually is from employee table, and ESSN is from dependent table, okay, equal. And the other condition using AND, exits, select star from department where SSN equal manager SSN. SSN, the first one, is from employee table, and manager SSN is from department table, okay. And we use AND. That means this one should be true and the other one should be true. If both of them are true, we show the first name and the last name of the employee. So, the queries, this query will select the employee for each tuple and then use SSN to check the dependent or department that this man is this man has any dependent or not. The first one, check any dependent, and the other checked the position of the man, that he is a manager or not. If the first one is true, he has some dependent, using exit, right? Exit is mean if the set is not now, it's returned to true. And if they select here, retrieve the man is a manager, the result here is not now, is return true also. And then after true and true, we show the man first name and last name. If one of them is false, so false and true, or true and false, or false and false, what is happened? the whole conditions is just become false because we use and, right? You have to remember the truth table. Okay, we use and. Nah. Okay. This one can use, we want to select ESSN. SSN is, social security number, like national ID, okay? From works on, from works on, where P&O, project number, in this set. So, the meaning of this one is we concern about 3 projects. Project number 1, project number 2, and project number 3. And we want to know ESSN of all people in these 3 projects. But sometimes one people work for 2 projects, so the data is duplicate, right? So we eliminate using this thing. Let's see. This one can use, we want to select ESSN. SSN is, social security number, like national ID, okay? From works on, from works on, where P&O, project number, in this set. So, the meaning of this one is we concern about 3 projects. Project number 1, project number 2, and project number 3. And we want to know ESSN of all people in these 3 projects. But sometimes one people work for 2 projects, so the data is duplicate, right? So we eliminate using this thing. Let's see. Similar, 5, 6 similar. Right? So there are duplication. We have to use this thing to eliminate. Distinct. Distinct. Okay. Uppercase. The concern. So the result reduced to just 4 tuples. Okay. Similar, 5, 6 similar. Right? So there are duplication. We have to use this thing to eliminate. Distinct. Distinct. Okay. Uppercase. The concern. So the result reduced to just 4 tuples. Okay. So you change the name in the result from last name to be employee name. And the last name here is supervisor name. Let's use this one. The join to create a new set of the data to be a new one. And this one is employee join with department on DNO equal department number. So from 2 tables they join together as 1 table. And then we select the data that the name, department name equal search from the new one. And show the first name, last name, and address. Let's see the result. First name, middle name, last name, SSN, birth date, address, sex, salary, a lot of things. And the other one, department, we have 1, 2, 3, 4, 5. 5. Oh, no. Dependent. Department, we have 1, 2, 3, 4. Just 4 columns. And employees, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 columns. Okay. And if we use just joy. อ๋ออยู่นี่ employee join if I use just join condition I would like to show you that the join okay ไม่ได้ไว้มันต้อง select join okay let's see this one join this is the result of the join the number where the number name okay the result show just 4 and we project the result that just 4 of them if we want to see the whole of the data we use select star so they show all of the columns from the table here from the result of the join but the condition is department name equal research so the result is quite very long because we join the employee and the department table already so we got the result here 1 2 3 4 5 6 7 8 9 10 11 12 result so it's like smaller because we don't want to know the others result we just have 3 of them we project only that yep so we got very small one first name last name and address that's all okay then result so it's like smaller because we don't want to know the others result we just have 3 of them we project only that yep so we got very small one first name last name and address that's all okay then and they said that natural join on two relations R and S are okay let's try some error a lot of error sorry too much join department meta okay let's see some error what is the error where clause from go still some error syntax to the name the department number the name research what is the error natural join from select from right where error is you have error in your query select the manual right syntax user DNO why I don't know sorry department name department we have 1 2 just one department number manager says start date okay and what is the problem natural joy department I'm not sure the syntax used near DNO you provide some issues yeah no they don't understand us okay give up sorry about that anyway you provide some issues yeah No, they don't understand us. Okay, give up. Sorry about that. Anyway, every tuple in left table must be appear in the result. But if the left result don't have any pair in the right table, so they will show the null value for attributes of the right table. And also right outer join. Every tuple in right table must appear in the result, but if no matching tuple, pad with null values for attribute of the left table. Next, we going to talk about the aggregate function in SQL. They have like a count, sum, max, mean, average. It become just single value from the result from table employee. Okay, from table employee. Okay, you can set the alias name for each column using using as. Here, oh, not this one. Here, for example, from this query, as max salary. Just the first one, I changed the name using as. Okay, the result will show max salary, just for easy to understand. Okay, I just changed just the first one, max salary, using as max salary. But the other, I just remain the result as this query. What else? And rename. We learn about nest query. Okay. What else? Aggregate function in SQL. Now value are discard when aggregate function are applied to a particular column. So, for example, query 20, find the sum of salaries of all employees of the research department, as well as the maximum salary, minimum, and average salary in this department. So, it's similar as the previous that we have tried, but they add the why? Because from employee table we don't know the name of the department. We know just the department number, but the question they identify that the department we want to focus on is the research, but the name of the department information is in the department table. Here is department name. So we have to use two tables. Then if you want the department name show in the result, so you have to join employee table and department table. You join them together, and then we can calculate something like find the maximum, find the average from this result. Okay. Yep. 4, because we calculate sum, max, mean, and average, right? Can we change anything? If we don't, no, this is impossible. Can we use inner join? Yes, they are similar. I will show you this one. If I use inner join and don't calculate anything, we show the result from the join. Okay, and department department name is research. This one is show inner joy. It's similar to the joy. But if I use natural, two tables has some of them with similar name to joy. Okay. What else? Two tables has some of them with similar name to joy. Okay. What else? Then we got the count everything. Just eight employees in this company. And number 22 here, name, DNO, the number. Okay, let's see. Okay, this is result, but we don't want to see anything. We want to just to count. So we use count employee, right? Count the employee, count the whole of them. Just actually 4 is the result that we want. Count the tuples from the result. Yes. Okay, this is result, but we don't want to see anything. We want to just to count. So we use count employee, right? Count the employee, count the whole of them. Just actually 4 is the result that we want. Count the tuples from the result. Yes. We want the same thing, that we want to count the employee in the research, right? But we forget from the D number. D number is from department. This one is very sure that is the research, because the name of research in this table. But this one is from the employee table. Oh, this one is not correct. So we want to eliminate them. But you have to think more. How? What you didn't add in the command. You have to recheck your result and how to solve it. But at least before you count, you should don't forget here group by DNO. So the result will separate count and average for each department. Okay, let's see. Don't forget here group by DNO. So the result will separate count and average for each department. Okay, let's see. Okay. Group by separate for each group. Okay. Group by separate for each group. Because in project we use P number and works on we use P and O. Group by P number, P name. What is the result? Let's see. Name and count the people who works on them, right? Yes. Because works on we have the data of the project and the employees in the project. So from this command we try to retrieve the number, calculate the number of the employee for each project. Yeah. Okay. And the other one is group by. Grouping, group by and having clause. Group by and having. Okay, now we're talking about having. Before, in previous, we're talking about group by already, okay? And next, we're talking about having clause. Provide a condition to select or reject an entire group. For example, here, for each project, on which more than 2 employees work. So we want to list the project that more than 2 employees work on the project. Retrieve the project number, project name, and the number of employees who works on the project.